Alright, so this video is to show you how to use a couple different tools to get your um, videos project done or video lab done. So one first thing is I remembered that Carleton College has some videos online that are already set up for doing physics with, and so I'll recommend that you use one of those rather than uh, making one of your own, although you certainly can make one of your own. And there's several to choose from, and I'll send you this link. Just as an example, I'm going to do this how fast is the ping pong ball. So I'm going to open that up, and so you can see the nice thing about some of these videos is they already have a scale on there on top of the video so that you can read distance right off the video. The other thing that's nice about these videos is you can go through them frame by frame. So I can play it and it's in slow motion. I can also scroll through, and then most helpful is I can go frame by frame, and then they tell you which frame number you're on and then how many frames per second. So what I've already done is I went through this video and I just wrote down in a spreadsheet on Google Docs what frame I was on. So I started taking data on frame 43, and I just read off where the front of the ping pong ball was, and I just went through frame by frame all the way through until I got to frame 55 and just took the distance. So you can see over here I have time and I have frame and distance data. This time column, because I want to figure out how fast it's actually going. So I want, rather than frames, I need to have it as an actual time. Just to make my graph, so what I did is I'm going to figure out how many seconds have gone by. So I'm going to say equals. And the first thing I'm going to do is I'm just going to subtract off 43 from this. So I'm just going to call frame 43 times 0. So in physics, it doesn't matter when we start timing something. It's just going to change, where our graph starts from. And I just like graphs to start from 0. It just simplifies things. So I'm subtracting off 43. And then from that number, I'm going to divide by 2600, since it was 2600 frames per second. And then what I do is I highlight the column, and then if I hit Control D, it'll fill that formula down, and so it'll figure out like what time I've gone in. The other thing I can do is so now this is time, and just to get in good habits, this is time in seconds, and this is distance in in centimeters. Oftentimes in physics, just to get a nice comparison, it's nice to know like centimeters per second doesn't mean a whole lot to me. I'm not used to seeing that. So I'm going to put distance in meters instead. And the reason why I'm doing this in Google Docs can plot, and it can do some basic line fitting, but not good enough for what we want to do. So we're going to be putting this into Plotly, but you can import directly from Google Docs to Plotly, so it's kind of nice. But this I'm using because I know how to use the formulas, and also I can show this to people, and then everybody has access to do it. So for distance, I'm just going to say that it equals the distance in centimeters and divided by 100, because there's 100 centimeters in a meter. And I suppose what I could do is I could set my distance to be initially 0 also, but that doesn't really matter. I mean, the other one didn't. So now I've got how many meters it's gone during that time. All right. So now that I have my data, what I do is I go to Plotly, which is just plot.ly. And it has you sign in, but you can sign in with any social media account, Google Plus. Or if you're signed into Google because you're already using Google, actually you're going to want just sign in with Google and then just use your Google account to sign into Plotly also. Because if you do that, if you're signed into Google already, then when you're in, you can just hit import and tell it to import from Google Drive. And it will open a pop-up, so if you have pop-ups disabled on your browser, it won't work. So you got to make sure you allow Plotly to open up pop-ups. So you can get this pop-up here, which will allow you to select data. So find the data that you have, and then open it up. Okay, and since we're all done with the video now, I'm just going to go ahead and go full screen with this so you can see it a little bit better. So here's my data, and you notice it took in my top line from Google, and it just applied those as the headers. And then for plotting it out, I have to choose what I want to be X. And so I want time to be X, time's always on my X, and I want distance to be Y. Hold on again. Gotta get the same color on here. So blue, blue. All right, so I've got time is X and distance is Y. And if it's not already selected, if you choose make a plot, and what you want to do is you want to do a scatter plot. So once I make the plot, over here, again, you choose a scatter plot. We're not going to choose any of these options. We don't need the error bars or things. And so then I'm just going to say to insert it into a new plot and then hit the button to do the scatter plot. And here's my data. And it's all nicely labeled for you with distance and time on there. Now it's a matter of hitting fit to fit the data. So you just tell it to add a fit. So if your data looks like a straight line, you can certainly make it linear. Mine looks like it slows down, like where it's getting less sloped over time. So that would actually be, if something's accelerating, it would be a quadratic fit. So I'm going to choose quadratic, and then I'm going to tell it to run this fit, and it will plot through there, and it will tell me what my R squared value is. If R squared is 1, it means it fits the data perfectly, and this just is underneath 1. If I look at my fit parameters, which are good to know, so you're going to want to make sure you know what your fit parameters are, okay? And maybe add them as a plot annotation would be a good idea, okay? So then you don't have to worry about them. Okay, so now I'm going to go back to my plot here. I think I can close this out. So I've got this added as an annotation, which is kind of nice, tells me everything. And so basically what this tells me is this first term, if you look at the equation, distance equals 1/2 at squared plus vit plus c. What it does is it tells me that this term is half of my acceleration, and this number is not, or actually it is a pretty big number. So it's negative, so it has a pretty large negative acceleration. I don't remember now if you know what, I chose centimeters, didn't I? That's okay. I'm just going to close out of this one. I'm just going to go back to my data. No, I did the meter. Well, whatever. Okay. So when it tells me what the main point of this was to get how fast it is going. So this term right here tells me my initial speed. And my initial speed was 240 meters per second. And so you can see it must be slowing down at a pretty big rate because that 240 meters per second is pretty fast for a ping pong ball to be going. So again, that's how you make the plot. All right. What I would suggest with this with these videos here, don't use this one. I already did it, so I'd like to see you do a different one. The accelerating cars are kind of nice because if you need to, you can watch this one at least in YouTube, but it doesn't have a scale the whole entire way. This ball on ramp would be a good one just because, again, it has a scale the entire way. You should get a nice smooth motion from that. So I guess I would recommend probably doing this one. Okay, hopefully that helps.